The technique has transformed the electron microscopy from a technique that could be used to just see the shapes, the outer shapes of molecules, into one that is now used to see the details, the atoms inside the molecules. And the latest technical developments occurred very recently. So it's very recent developments that we can actually see the details of these molecules. The technique is also relatively rapid, so once one has samples that can be studied, the structure can be determined relatively rapidly, and this was exemplified last year when the structure of the Zika virus was determined in just a few months, and it's seen here. And this structure shows the atomic details of the surface, which of course is important when developing drugs against the virus. But the technique is not only about seeing molecules, and I think this is fantastic for developments that has already started, but will be seen also in the future. And that is because the molecules are frozen in solution. If a molecule does some work like the one shown here, then all these molecules are frozen exactly in a moment, in the different states, in different structures, and it's like frames of a movie. Each of these pictures represents a frame, and they can be put together into a movie like the one shown here, and we can see what the molecules do. So I think in the future, this is not only about getting structures of molecules, which are in itself, it's of course fantastic, but it's also for the future, we'll be able to see processes, what is happening, what is going on inside the cells, how do the molecules interact, how do they move, what do they do. And I end this presentation by showing the laureates again. Thank you.
Thank you, Peter.